Yes. Yeah. Yeah. Good evening, all. Right. So we had a session right previously. Right. I was just briefing you about what is big data, why Hadoop and Spark, drawbacks with the current databases, advantage of Hadoop and Spark, right? The Hadoop and Spark job market and impacts. So here Hadoop is meant for two things. Hadoop is meant for both storage and for processing. Hadoop is meant for storing as well as processing. Any technology performs storage or processing, but Hadoop performs both storage and processing. For storage, does it use any database? No, databases has got some drawbacks. Despite of those drawbacks, still Hadoop doesn't go with databases. It is going with a kind of file system called Hadoop distributed file system. For processing, MapReduce or Spark. Hadoop is meant for batch applications. Hadoop is not for online applications. Online applications means user interactive application. User gives the input, but in batch applications, user doesn't give any input. User non-interactive applications. Credit card statements for millions of customers. Example, right? Generating credit card statements for millions of customers here, user input is nowhere required. But if it booking a movie ticket, user input is required. Making an online transaction, user input is required, right? I was talking about in the previously, I was talking about drawbacks with the current databases. Most of the databases are limited storage, no parallel processing. If volume increases, speed decreases. The volume of the data is increasing. Total amount from sales one, total amount from sales two, total amount from sales three. 10 records, 10 lakh records, 10 crore records. Record to record, right? If the volume increasing, if the volume is increasing, speed decreasing, right? Yes. Even if complexity increases, the speed decreases, right? Even if complexity increases, speed decreases. Total amount, the average amount, standard deviation of amount. Here, average amount takes more time, right? As compared with the sum. First sum to be calculated, next average has to be computed. As compared to this, average amount takes more time. Standard deviation of amount. Standard deviation of amount, right? Lot of internal processing is required. Lot of internal processing is required. Databases can handle only structured data. They cannot handle unstructured or semi-structured data. So major these are the major drawbacks, right? With the databases. We come to this Hadoop advantages, right? Hadoop advantages. Unlimited data storage. Unlimited data can be stored. Unlimited data storage. Horizontally unlimited number of unlimited slaves. Very high speed processing because of parallel processing. Can handle all varieties of data, structured, unstructured, and semi-structured. It's open source. No licensing is required. Commodity hardware. Can run on all the hardwares. Doesn't mean that it should have highly configured, right? It can run on any heavy hardware configuration. Why databases like Oracle cannot support unlimited storage? Even databases can go with multiple systems or multiple slaves. Talk about these databases and max limit on the number of slaves. Oracle can go with a maximum 256 nodes for storing its data. MySQL with 54. MySQL Express with 256. SQL Server 256. DB to 256. Teradata can go with a maximum 512 nodes. Teradata, and Vertica. They're used for data warehouse, right? Specialized databases used for data warehouse purpose. So all these three 512 nodes. But these two, Teradata and Netezza, currently they are going with 1024 nodes for storing its data. So here, but there is no limit on the number of slaves that Hadoop can have, right? Yahoo, when first time implemented Hadoop, went with 4,000 nodes for storing its data. Currently, Yahoo going with 12,000 nodes for storing its data. Systems, nodes means systems. Facebook, when first time implemented Hadoop, went with 8,000 nodes for storing its data. Currently, Facebook going with 52,000 nodes for storing its data. So if you see the speed, if you see the speeding, this is what Hadoop is prevent storage point of view and even processing point of view. If we talk, has taken a table. Yahoo has taken a table to check the speed of different databases. Has taken a table of 100 TB consisting of 1024 columns. Task sorting based on 16 columns. Time taken, right? Oracle has taken nearly 3.5 days to process. MySQL, right? It has taken nearly 6 days. Teradata, like 4.5 hours. Netezza, 3 hours. Hadoop, 3.4 minutes. Latest version of Hadoop has just taken 1.2 minutes. Okay, so these have taken days of time. These have taken hours of time, but Hadoop has taken minutes of time. But even Hadoop has got very high speed, right? Hadoop has got very high speed. But Spark is 100 times faster than Hadoop. Spark is 100 times faster than Hadoop. See the speed of Spark. Already Hadoop has got very high speed where it has taken only minutes of time. But Spark is 100 times faster. Okay. So very high speed processing, right? Both Hadoop and Spark commonly used together, right? Yes. So now, how exactly data stored? See how exactly. See, before that, I was discussing about architecture, right? Yes, if you observe, Hadoop was just talking about this. Hadoop doesn't follow client server. Hadoop doesn't follow client server architecture. It doesn't follow client server architecture. Hadoop follows a master slave architecture. It follows master slave architecture. It follows master slave, single master, multiple slaves architecture. Hadoop cluster means group of nodes, group of nodes means systems connected in a network, connected in a network. Hadoop cluster means group of nodes, systems connected in a network. There are two types of nodes, master node, slave node. There are two types of nodes, master node and slave node. Master node, we call it as a name node. Slave node in Hadoop terminology like a data node. Master node responsibilities, yes. Task assignment, load balancing, assigning tasks to the slave systems. The task should be equally given to all the slaves. If the fault tolerance means if any systems fails, multiple tasks are executed by multiple systems parallelly. If any one slave, if any one slave fails, then the task of it has to be assigned to any of the other slaves. Health monitoring. Health monitoring, right? Yes. Okay. Slave node responsibilities, storing the data and processing the data. Slave node, okay, just observe this diagram once. Hadoop follows master and slave architecture, single master and multiple slaves. S1, S2, S3 up to Sn. So this is master, these are slaves. Master node. This is slave node. Slave nodes we call it as data nodes. Means data stored within the slaves, data processed by the slaves. Means if we talk about any file f1.txt, this we call it as a cluster, group of systems connected in a network. Group of systems connected in a network. Two types of nodes, master node, slave node. Group of nodes connected in a network. One is master, remaining all are slaves or data nodes. So f1.txt, you have got a file f1.txt. We have got f1.txt. The file, for example, each system capacity 1 TB, 1 TB, 1 TB, 1 TB. This file size is 2 TB. It cannot fit into any of the slave systems. It has to be divided into smaller parts and has to be distributed across multiple systems. The advantage we see is distributed. Data is distributed across multiple systems and data is processed by multiple systems. Data stored across multiple systems. Data processed by multiple systems parallelly. Data stored across multiple systems and data processed by multiple systems parallelly. Distributed storage and parallel processing. Right. How exactly the data stored and processed, right? How exactly the data stored and processed in Hadoop. In Hadoop, data is stored in the form of files. In Hadoop, data is stored in the form of files. Each file again, each file is again subdivided into subdivided. File is again subdivided into blocks. File is again subdivided into blocks. Blocks are distributed. Multiple slave nodes and are processed. Blocks are distributed across multiple slave nodes and are processed. Default block size. Default block size is 64 MB. Latest versions, it is 128 MB. Default block size 64 MB. In latest versions, it is 128 MB. For example, I got f1.txt. Size is 200 MB. f1.txt size is 200 MB. Assume it is some banking data. It has got some banking data. Default block size. Assume the default block size is 64 MB. Default block size 64 MB. Number of blocks into how many blocks? Number of blocks. File size by default block. File size by default block size. So d f1.txt size is 200 MB. It has got banking data, right? Default block size 64 MB. Number of blocks. File size by default block size. File size is what? 200. 200 by 64. 200 by 64 means like approximately right 4 blocks. Approximately 4 blocks. B1, B2 means 64, 64, 64. 192 you will get plus 8 MB. Fourth block. Fourth block has got 8 MB. B2, B1, B2, observe here, B3, B4. B1 block, B1 block 64 MB. B1 block has got 64 MB. B1 block 64 MB. B2 block also like 64 MB. B3 block also 64 MB is stored. In B4 also 64 MB. Sorry, in B4 8 MB only. 8 MB only. 64, 64, 64 means 192. 8 MB only in the means 56 MB free here. 56 MB free. I got F2 dot same thing. Same thing I'll copy. There's one more file. Assume you got one more file. F2.txt. Size exactly 192. Assume that you got some telecom data. Default block size 64. Number of blocks 192 by 64. Exactly 3 blocks. So here B5, B6, B7, B5 has got 64 numbers. So these are stored in which system? System start system 1. This in system 2. This in system 3. B5, B6, B7 also they are storing 64 MB, 64 MB, 64 MB. 64 MB in this, 64 MB in this, 64 MB in this. S4, S5, S6. Here the is 56 MB is here. Why this B5 data is not stored in this B4? 56 MB is free. When 56 MB is free, why B5 data not stored in B4? retrieving f1.txt. Retrieving f1.txt is combining the b1 plus b2 plus b3 plus b4. b1 plus b2 block plus b3 plus b4. Retrieving f1.txt, right? Okay. If b data, assume that if b data stored in b4, assume if data stored in b4. If b data stored in b4, right? For example, 64, 64, 64, 64 plus 8 plus 8 MB plus 56 MB equal to 256 MB. MB, but actual file size is 200 MB. So long computation, right? When we retrieved f1.txt, when we retrieved f1.txt, design principles with respect to HDFS blocks. HDFS blocks. Design principles with respect to HDFS blocks. Every file should have dedicated number of blocks. Dedicated number of blocks. Every file should have dedicated number of blocks. Means file 1 should have its own blocks, a file 2 should have its own blocks. In a single block, no two files data. In a single block, right? No two files data to be stored. In a single block, no two files data to be stored. Every file dedicated a block in a single block, no two files data to be stored. every block will have equal volume. Except the last block. Every file should have a dedicated number of blocks. In a single block, no two files data to be stored. Every block will have equal volume except the last block. Except the last block means everything having equal volume. See, 64, 64, 64. Only the last block less. Configuring block size. Configuring a block size. Configuring means increasing or decreasing. Increasing or decreasing the block size. Go to the Hadoop install directory. Go to the Hadoop install directory. In that HD, we'll see one file with the name hdfs-site.xml. One XML file will see. It's an empty file. You will see. Open this file. It's an empty file. Open this file and configure the following. Open this file and configure the following. Go to the Hadoop install directory. You will see hdfs-site. Open this file and configure the file. It's an empty file. So just XML means your tags. Configuration, opening. This is it as closing. /configuration. This we can close within the property. Property and /property. Within this property, right? Property name dfs.block.size. dfs.block.size /name value for this. See, by default it is 128 or 64 MB, 64 128. By default, if you're not specifying anything, it takes 128 MB. If you want to keep 50 MB as my default block size, or 100 MB, or 150 MB, or 30 MB, whatever you want to keep, you can keep it. You can configure your own block size. Means your file will be divided, your data file will be divided into this fixed size. Each size will be 50 MB or 100 MB. For example, you have got 1 GB file, like 1000 MB file, 1024. Divided, if you take 100 in 100 here, 100, nearly like 11 time. In this way, you can also set your own block size, right? Yes. I will discuss 4 cases here. Just observe here. I'm going to discuss 4 cases.
So if we decrease, if we place the watch default size is 128, right? So while increasing the data retrieve is fast. If we place the example one block size is 200 MB like that, so the default 128, we can increase also. You're saying that.
Yes,
Less
yes.
less blocks means it will fast fetching anything difference will come.
Yeah, yeah. And yes, I was just about to ask the same query. So the
Okay.
same query,
Okay.
which is advantageous. Having a bigger default block size or smaller, smaller default block size. Mm. Try to answer anyone as per your knowledge, which is advantageous. I'm saying you can set your own block size. So if you are setting bigger default block size or small,
Sir, it's depends on data, right? So if you have a huge data, you can split it, right? So based on that, smaller default block size is better, sir.
okay, just observe this. Example, I got f1.txt, f1.txt, 1000 MB. I'm taking default block size taken as 500 MB, 500 MB. How many blocks?
Two blocks we can split.
Two blocks. Is it advantageous? If you have, if you have 40 nodes in that data is stored, data is stored in only hmm, two nodes and data processed by two nodes only. Data processed by two nodes only. But less speed. If it was default block size, At least, at least around 10 systems should be running parallel. So lesser speed means just a labor example. You brought for a building construction, you brought 40 labors. In that, you are giving work to only 2 labors. Remaining 38 labors are free, right? If you are given that work to all the labors, should have been high speed. You should have got high speed, right? So got high speed. So that means even if data is stored, if you are taking like bigger default block size, they want to be distributed on all that systems. Only less number of systems the data gets distributed. Only less number of slaves will be, yes, running parallelly. You won't achieve that much of speed, right? Yes. And what happens if I take less block size? Is it advantageous? Hmm. For example, as this example, f2.txt and maybe only default blocks taken in MB. Hmm. Number of blocks, 10 blocks. Is it advantage? Is it advantage? Already, already it is a very small file. Very small file. And dividing into smaller parts. Again dividing into smaller parts. Distributing across multiple systems. Processing. Later combining the result. And later combining the result. Later combining the result. The time taking process. So the blocks should not be too big or too small. The block size should not be too small. That's again Hadoop has given default block size. I don't get MB. Still, okay, depending some as I said, right? Even depending upon the data also, you can increase or decrease. Depending upon your cluster capacity, depending upon the incoming data, you can also decrease or increase, right? Based on that, what speed you are expecting. So you cannot have too much big or too much small. Okay, understood, right? Yes. This is what default block size. We can also configure, I'm saying. Yes. Now I'm going to discuss 4 cases.
So it's a small doubt here. The file size is like the documents and how that's variable.
One second, this way.
See that, okay. Based on the conversation I got out, so that's why I asked.
First here, I'm going to discuss 3 cases. 3 cases. In that case 1 is number of blocks equal to number of slaves. What was that? What was that you asked? If block size?
The block size is 128 MB. So the file up less than block size means how we divide into the block like did it go to the first block only or again it will also divide one block? Yeah.
It has got 64 MB. If it has got 8 MB, the 8 MB will be storing, but remaining will be free.
Okay. Yeah, that only so.
Number of blocks equal to number of steps. Number of steps. So I think that you got 4 blocks. You got 4 systems. Number of blocks means B2, B3, B4, B4. You got 4 blocks. Slaves like S1, S2, S3, S4. How exactly the data stored and processed here? How exactly the data stored and processed in
Sir, I have a small doubt here. Sir, each block, while transferring the data, it's fully coded or something will be kept for storage.
each block? One second.
If B1 has the 64 MB data, 64 MB storage, sir. So 100 MB data is coming enter into the B1. Is that fully loaded 61 MB or something? Some storage will be kept like
See, very very simple, right? Okay. What? 10 blocks are there. 10 blocks are there. 64 MB. Assume that your file is divided into 10 blocks.
okay.
4 MB blocks. F1.txt. F1.txt, right? 10 blocks. You have got how many systems? 5 systems are there.
Yes.
5, 1, 3, 4, 5. Please be in with 5 systems are there. The system 1, system 2, system 3, system 4, system 4, system 5. But 10 blocks are, how these 10 blocks are going to be stored into this 5 systems? First, B1, B2, B1, B2, B3, B4, B5. Again, B6, B7, B8, B9, B10. Means each system storing 2 blocks. Each system will have equal value. Only that B10 will have the less value. Anytime you see whatever the file size, only the last block will have that less size. B1, B2, B3, B4, B5. But if you got only 2 systems, S1 and S2, in S1 5 blocks will be stored, in S2 5 blocks will be stored. Means all will have equal volume except the last one will have less value. So depends upon the number of systems, the blocks are distributed. Means whatever might be your file size, whatever your work is what, just specifying the block size. Automatically, rest is going to take care by itself. Means it is going to divide into blocks, and the blocks it is going to distribute across multiple systems. But everything taken care by the Hadoop framework itself. So whatever the size it is, divides into blocks and stored across it. Because you'll be storing, you'll be maintaining a cluster with multiple systems. So they'll be distributed across. But okay, the difference in the speed you will be observing. That what I'm discussing that next. We're going to discuss 3 cases now. If the number of blocks equal to number of slaves, very high speed you see. Very high speed. For example, F1.txt size 230 MB. Assume default block size is 64 MB. Number of blocks how many? 230 by 64 means 4 blocks. How these 4 blocks are? Like B1, B3, B1, B2, B3, B4. How is 4 blocks stored across 4 systems? 4 blocks. Think that each block of lakh records, 10 lakh records, 10 lakh records. This V4 has got some 5 lakh records. How these blocks are stored across multiple systems. This is the master node. These are the slave nodes. How many slaves? 4 slaves. 4 slaves. This one slave. This one slave. This is one slave. 4 slaves. S1, S2, S3, S4. So B1 stored here, B2 stored here, B3 stored here. Data distributed. Data is divided into blocks. These blocks are stored across multiple systems. Right? Yes. So this is the master node. This is the master node. These are the data slaves. Slave nodes we call it as data nodes. Right. Master node. Within the master node, we say it as name node. We have got a name node. Name node contains metadata. Metadata means data about data. It won't store the data, but the data about data. Data about data. F1.txt divided into how many blocks? B1, B2, B3, B4. Where B1 is stored in S1, where B2 is where B3 in S3, where B4 is stored. Right? This information, this everything will be stored within this name node. Name node stores the metadata information. This is how the data is stored. Thus 4 blocks. The blocks are distributed across multiple systems. Data processing, if you are data processing, job is process F1.txt. Always job will be divided into tasks. Job always divides into tasks. Number of tasks. Job will be divided into tasks. Number of tasks equal to number of unique blocks. Number of unique blocks. Number of unique blocks how many? 4 blocks. 4 blocks means 4 tasks. 4 tasks. Job to class F1.txt. Yes. How many tasks? T1, T2, T3, T4. T1 task is for executing B1. For executing B1 10 lakh records. T2 task is for executing B2. T3 is for B3. T4 is for B4. Right? Who should execute this T1 task? Which system has to execute T1 task? As B1 is present in S1, S1 only should execute, right? Who should execute this T2 task? Which system has to execute? Hello? T2 task should be executed by T2 means B2. Executing B2 is slave to S1 only should execute. S1, S2, this one, S4. Means here 4 tasks. Means T1, T2, T3, T4 are executed. Are executed by 4 slaves. S1, S2, S3, S4 parallelly. No waiting state. All are executed parallelly. Right? That's why very high speed. None of the task is in a waiting state. But if you observe this case 2, some tasks will be in the waiting state. That's why case 2 observe. Number of blocks. Blocks are slaves are less. In this case, let's see how come 4 blocks are there, 2 slaves are there. So B1, B2, B3, B4. 4 blocks. How many slaves? 2 slaves. S1, S2. F1.txt. F1.txt. 230 MB. Default block size. Assume 64 MB. Number of blocks. 230 by 64 blocks. 4 blocks means B1, B2, B3, B4. How these 4 blocks would have processed? Master and multiple, 2 only. In that less number of slaves. How this data is distributed? This we call as master node. Within the, okay. Here B1, here B2. Again B3, B4. Yes. This is S1, this is S2. Here F.txt divided 4 blocks B1, B2, B3, B4. Where this within this master node, we got a name node contains metadata. Metadata means about data. B1 by S1, B2 by S2, B3 again S1, B4 again S2. This is how the data is distributed across multiple systems. Fine. We talk about this data processing. We talk about a job to process F1.txt. Job process.txt divided into tasks. Number of tasks. Always number of tasks depends on number of unique blocks. 5 unique blocks here. Why with the name unique? I'll say here 4 blocks, right? 4 blocks means number of tasks equal to 4 tasks. 4 tasks. Job f1.txt divided into 4 tasks. T1, T2, T3, T4. T1 for executing B1, T2 for executing B2, T3 for executing B3, T4 for executing 4 blocks. Who should execute this T1 now? Right side. Who should execute? Which system has to execute this T1? This B1. So,
Yeah, it's a B1, right? It's a B1 plan will execute.
T2 system.
System one.
T2.
System one.
T2 B2 present in S2. System 2 only. This B2 block present in S2. So S1 should execute on S1 cannot execute. So T3 for executing B3. B3 is stored in S1 means S1 only execute. B4 is present in S2.
So is that alternative?
Not alternative. If B1 B2 is stored in S2 block wise, B4 is right. So whatever it's 4 blocks are there, 2 stores in this case. S1 finger. 2 blocks. S1 should execute 2 tasks. S1 should execute 2 tasks. Very simple. Right? Take a level example. Are there. Only 2 level persons are there. If 4 tasks are there, only 2 persons are there. You will assign 2 tasks to this person. You will assign 2 tasks to this person. Whatever it is. You are assigning 2 tasks to here. You are assigning 2 tasks here. Two tasks. Means when here only one task can be executed. When T1 is executing, T3 will be in the waiting state here. When T2 is executing, T4 will be in the waiting state. Means only 2 tasks are executed parallelly. Remaining 2 are in the waiting. Think that 40 tasks, 20 slaves only are there. These 20 slaves can execute 20 tasks parallelly. Remaining 20 will be in the waiting state. Means once these 20 tasks got completed, the next 20 tasks still execute. Here also, once T1, T2 complete execution finish, next will execute T3, T4. Means some tasks are in the waiting. That's why I'm saying lesser speed. In the case 3, if you observe this case 3, right? In case of case 3, more blocks, only one slave. More blocks, only one slave. More blocks means 4 blocks. One slave. S1. B1, B2, B3, B4. Only one slave. B1, B2, B3, only one slave. 4 blocks, only one slave. Means one master, one slave. S1. Here only all the slaves B1, B2, B4. This master name node stores the metadata .txt into 4. B1, B2, B3, B4. B1 by S1 on B2 also S1, B3 also S1, B4 also S1. Even if you talk about this data processing, job to process F1.txt divided into tasks. Task nothing but number of unique blocks. How many blocks? 4. 4 tasks means 4 tasks. 4 tasks means T1, T2, T3, T4. These 4 tasks to be executed by S1 only, S1 only, S1 only, S1 only. Sequentially, one after the other. No parallel processing here. 4 tasks executed by 4. Means this 4 tasks should be executed by S1 only, sequentially one after the other. No parallel processing. No parallel processing means here if motives more speed, less slaves, less speed. Only one slave, no helps. Just like you've got labors, building construction, more labors, building construction will be fast. Less labor will be slow. Only one labor, right? Sort of in the same way here. But I got a query here. If you go back to this one, if it's case one, right? Here, T1 task assigned to S1, T2 to S2, T3 to S3, because 4 blocks, 4 slaves, 4 tasks assigned to 4 slaves. Okay, this T1, T2, T3, T4 are executed by 4 slaves, S1, S2, S4. Suddenly, these are means 4 tasks executed by 4 systems parallelly. Suddenly, if any one system goes down, then suddenly if any one system goes down, then 10 lakh records are lost. You can see 2 drawbacks here. 10 lakh records are lost. This task is failed. If 2 tasks is failed, then job will be failed. Yes, 2 tasks is failed, job will be failed. This 10 lakh records, if it is sensitive data like banking data, 10 lakh records, say useless. If it is insensitive data like Facebook data, it's not right. So how Hadoop is overcome? How Hadoop is going to overcome this? There's a concept called replication, and fault tolerance. Fault tolerance. Replication and fault tolerance. Replication means duplication. Duplicate data is 2 and 2, then we'll be duplicating the box. B1, B2, B3. Default replications 3. Then we'll duplicating. Even if one slave is done, still you have got that duplication. Still there won't be any data loss. Even there won't be any task value, right? With that replication and fault tolerance. Fault tolerance means any one system is done, then the task will be running of the other system. That is fault tolerance. Okay. So replication and fault tolerance decision we'll be discussing it, right? Understood how exactly a student process in how it is divided into blocks, and how the blocks are multiple systems, what is the default block size, how to configure the block size, and yes. In the next session, I will be discussing the fault tolerance application and how to storage architecture and processing architecture. How to storage and processing architecture, and I'll be discussing about the software. The software will be providing to your Google Drive. You can download from there and can how I'll be demonstrating about it in this class. Fine. So yes, so total concentration of this Python, right? Spark with Python, right? Yes. So I said Spark with Python implementation. So when I'm discussing Hadoop, people can have knowledge of this Python. You'll be updating with Python parallelly. Hadoop and Python. This will be from Monday to Friday, and it's my batch, right? Python batch. So 9 a.m. batch is there for Python, Monday to Friday. 6 a.m. batch also. If anyone wants morning, they go 6 a.m.